Hey, we start a new unit today, so we're leaving Unit 1. Unit 2 is going to be quadratic functions. So we're leaving line land and heading into curve land. Some of these, all the functions from now on will be curves, some more wiggly than others, but that's beside the point, because today we're going to factor quadratic expressions. Let's get started, shall we? So first we're going to start someplace familiar. We're going to multiply a couple binomials. You probably recall the process here, but let's see. We're going to take each term in the first binomial and multiply it with each term in the second binomial. So x times x, x times 8, negative 4 times x, and negative 4 times 8. So we end up with 4 terms, but 2 of them are like terms, and we can always combine like terms. So the final answer, simplified answer, is this right here. X squared plus 4x minus 32. Now this is a product, and what we're going to do today is go from here backwards to the factors of this particular quadratic expression. This is a quadratic expression. So let's take a shot at that. So we first need to talk about the standard form of a quadratic expression, and it's ax squared plus bx plus c. Alright, by the way, this is number 7 on your video notes. So we're going to do some problems from your video notes, and there's a couple that aren't on there. But now in this problem, what I need you to recognize is that the a is equal to 1. So there's really a coefficient in front of this x, and it's 1. And that's going to make this particular problem a little easier to factor. Our strategy will be different than if there was something in front of the x squared. So here's one thing that does for us. Since there's a 1 in front of that x, we know that there's only one way to get the first term of the two binomials that's going to produce that equation, that expression, and that's to put an x and an x in front. There's no other way to get x squared than to multiply x times x. So our strategy for finding out what else goes in these binomials is to focus on the last term and the middle term. Okay, and we're going to ask ourselves a question. We're going to ask ourselves what multiplies to give me 30, the last term, but also adds to give me 7, the middle term. Now we could go ahead and put negative 30 here, because that is the product we absolutely need. But I usually just start listing factors and see to expose the pair that's going to produce a 7. Let me just go through this, and I think it'll become clear to you. So the factors of 30: 1 and 30, 2 and 15, 3 and 10, 5 and 6. So I'm going to go through this list, these pairs of factors, and I'm asking myself which two of these which pair is going to produce a 7. And for instance, if I was to focus on this 2 and 15 here, I could add those together and get 17. I could subtract them and get a 13. So these guys aren't good candidates. They're not going to produce a 7. However, as you can probably already recognize, 3 and 10 could definitely produce a negative 7 if I had a negative 10. So 3 plus negative 10 equals negative 7. So here are our candidates for our binomials, these two factors. 5 and 6 are not going to produce a 7. 1 and 30 are definitely not going to produce a 7. So I just go up here now. Positive 3 and negative 10 are my numbers. I'm going to put plus 3 here and minus 10 here. Now let's multiply this back out, and it'll kind of expose this whole thinking over here, why we went through this process, why it works. Okay, what multiplies to give me 30 and adds to give me 7? What multiplies to give me negative 30 adds to give me negative 7? So we'll go through this like we did before. So that's x squared minus 10x plus 3x minus 30. And what you can tell is that indeed this minus 30, the negative 30, comes from a product. 3 and 10, it was a product. That's why we ask what multiplies to give me negative 30. And the middle two terms are combined. Okay, they're being added together, so to speak. You could also, well, they're being added together, and that's why we ask ourselves, what adds to give me negative 7? And if you go through this process when a is 1, it's going to help you zero in on the two binomials that result as factors of the original expression. So in this case, you might be saying, hey, Mr. Palmer, a does not equal 1. And that's true. Good observation. When we have quadratic expressions that don't have a 1 in front of the x squared, we're going to need a different strategy to think about them. They're a little bit more interesting to factor. So in this case, however, let's see if that 5 can be taken out. Let's see if there's a greatest common factor in each of these terms. So you always ask yourself this when you're factoring. You always ask yourself, can I take out something? Well, each of these terms has something common, a common factor, and the common factor is 5. So if I take a 5 out of each of those terms, I'm dividing 5x squared by 5, I'm dividing 40x by 5, and I'm dividing 75 by 5. So if I take a 5 out, 5 is my common factor. Now what that's done, it's kind of nice that I now have a simplified quadratic expression, and I can approach it just like we uncovered on the last slide. So I can ask what multiplies to give me 15 and adds to give me 8. Well, this time things might be a little simpler because there aren't too many factor pairs for 15. We got 1 and 15, and we have 3 and 5. And it becomes pretty apparent quickly for you that these are the guys that are going to produce an 8 for me. 3 plus 5 equals 8. So those are the numbers that I'm going to put into the binomials that are factors. The 5 has to come along. It's part of our answer now. Alright, there's only one way to get x squared, and that's to put x in those two spots. And we're going to put plus 3 and plus 5 because that's what we have over here, plus 3 and 5. It wouldn't matter which spot those are in. You could switch them and you'd still get the same answer. So that was number 12 on your video notes. Didn't mention that at first, but now these look different, and what you can immediately see is they aren't trinomials, they're binomials. They're not in standard form, so to speak, because there's the middle term's gone. These are a special case, and we like special cases because typically maybe they factor a little easier for us. So this is called a difference of squares, and these two problems aren't on your notes, but there are problems like them there. Difference of squares. So here's the pattern that we want to show you. A squared minus b squared always factors into a plus b times a minus b. So if you were to multiply these two binomials right here, like we did in the very first slide, you would end up with something that looks like that. So really all you have to do is find the a and the b. What's being squared in the problem? Well, since this is a binomial and these look suspiciously like squares, that one's pretty obvious. It's staring you in the face, and this, I kind of remember that as being 6 squared. So really we have x squared minus 6 squared. X, our a equals x, and our b equals 6. So this is going to factor into x plus 6 times x minus 6. A difference of squares always factors pretty nicely. All you got to do is find what's being squared. So over here we have another problem, and you know, well, the 144, most folks can remember that from grade school as one of those squares that we memorized. So that's 12 squared, so our b is 12. This one may not be as readily apparent, but and some people might even want to take something out of these two, like a GCF, but your first thought when you see a binomial and a minus sign, here's a binomial and here's a minus sign, your first thought should be, hey, is that a difference of squares? Let's check and make sure. And in this case it is. It's 2x squared. You square 2x, you get 4x squared, okay? So in this case our a is 2x and our b is 12. And this factors into 2x minus 12 and 2x plus 12. Simple as that. Doesn't matter if you put the minus or plus first. The bottom line is you always get this pattern right here when you find a difference of squares. So we've uncovered so far a few strategies to get us going on factoring quadratics. We'll learn several more. The greatest common factor is the very first thing you always check, because that'll simplify your life. We just saw a special case. If you can uncover a difference of squares, it factors very nicely. And then what we did early on is this, trial and error. We had a's equal to 1, which made things a little nicer. It gave us a little structure to ask what multiplies to give us the last term and adds to give us the middle term. And that helped us kind of get going as far as guessing and checking what the quadratic expression would factor into. So finish up the video note problems, and we'll talk tomorrow.